Hello, ladies and gentlemen, and welcome back. We are on the last question, question number 4 of our 2013 Galois paper. So let's dive in and take a look-see. A cube with edge length 9 centimeters contains a certain amount of water. Okay. A part. When the cube has one face resting on the ground, the depth of the water is 1 centimeter, as shown. What is the volume of the water in the cube? Okay, that's not that bad. The water forms a prism. So a square-based prism. So the volume is the 1 centimeter height, and then it's 9 centimeter by 9 centimeter because it's a cube. Okay, so that's 81 centimeters cubed. That's the volume of the water. We just need this final answer, but we have shown our work because it's a light bulb question, and that's usually what I do. I show a little bit of work. All right, now B part. The cube is turned so that one edge, PQ, is on the ground with opposite edge, MN, directly above it. Calculate the depth of the water in the cube. All right, so here's where it might be good to actually have a proper, some visualization. Sometimes you can bring little things to the test as long as it doesn't have anything written on them. Not always, okay, but I've never seen a student get like a Rubik's Cube taken away. Not that I don't work for Rubik's. I'm not plugging Rubik's Cubes. I just like Rubik's Cubes. And I happen to have one handy. So, you know, if you have if you have difficulty visualizing these things, having a prop or being able to use some scissors and some scrap paper to quickly construct one for you can help you visualize. So if I just want my cube, I'll use my tablet here. So I imagine my cube with the edge and this edge right above it. How's the water going to pool? Well, the gravity's going to pull it down, and it's going to sort of pool along the base here, and we'll almost get sort of a triangular prism. And the triangle will be, well, just based on symmetry, I'm going to guess isosceles and things like that. So having a little prop can sometimes help you out. That back there, shall we? Okay, so let's actually draw a picture of this so that maybe we can refer to it when we're writing up our solution. So, what do we want to say? Oh, I've lost focus. There we go. I'm gonna start on another page. Something like that. Alright, so there's PQ. And so the water is going to just it's going to be level. And based on the symmetry of the whole thing, it's going to be nice and isosceles. So this will come back here and then fill that in there. And we'll use the light blue to maybe fill this in with water. Was it water? It was water, not just some generic liquid, right? Yeah, it's got water. Okay. So we can see the water should, let's say, collect. It seems like a good word for it. So the water should collect at the base as a triangular prism. And we can even say as shown. Alright, so by symmetry, and we can attach some points here. I'm going to say A here and B here. By symmetry, the triangle is isosceles. Alright, now from A, we know the volume is 81 centimeters cubed. So this is from A. How do you find the volume of a prism? Well, it's the area of the one side and then times the total length here, which is going to be the same 9 centimeters. So the area of triangle PAB times 9 centimeters. So what does that tell me? That tells me the area of triangle PAB, well, just dividing both sides by 9 must be 9 centimeters squared. Right? Because in total we've got 81 centimeters cubed, so divide by 9 centimeters. Centimeters goes down by 1, 81 over 9, 9. So we'll get 9 centimeters squared. Okay, but now, what do we want? We want the height here. And, I can see, because it's in the corner here, PAB is right angle. There's what I can see. So, angle APB is 90 degrees. You could say something like it's in the corner of the square, or whatever you want to. So, we've got put P here, A here, B here. So because it's isosceles, AP is equal to PB. We'll call this X and X. So 9 centimeters squared is 1/2 X centimeters times X centimeters. So 18 centimeters squared is X squared. So X is square root of 18. Now, I don't think we wanted that. What did we want? We want the depth of the water. Let's say the depth of the water is... I can draw a better isosceles right angle triangle than that. So the depth of the water is PM in my little picture. It's the altitude here. It also cuts it right in half by symmetry. You can say that again if you need to. And so PM, well, this is 45 degrees because it was originally, because it's an isosceles right angle triangle. So this is 45. So PM is equal to AM. PM squared plus AM squared is equal to AP squared, but that's square root of 18 squared. So that's 18. So 2 PM squared is 18. PM squared is 9 centimeters squared. So PM is going to be 3 centimeters. So water depth is 3 centimeters. There we go. Okay. So that's B part. What have we got for C part? The cube is now positioned so that a single corner P is on the ground with the opposite corner N directly above it. To the nearest hundredth of a centimeter, calculate the depth of the water in the cube. So I could bring back the prop. If I was having trouble visualizing it, I think I'll be fine. Picture-wise, let's see what we can draw here. Not the best artist. Otherwise, this would be an art channel, not a math channel. M is right above, P is down here, and everything's just going to sort of, once again, pool around that corner. But it's not going to be a prism. It's going to be almost sort of like a well, it will be a tetrahedron because it'll have 4 sides, but it won't be a regular tetrahedron necessarily. Okay. We see the water takes the shape. We can give these things names, A, B, and C again. So shape of you might call it a right tetrahedron because all the angles in here are right angles. P, A, B, C. That's a fine thing to say. Okay. So, what do we want? We want the depth of the water again, right? To the nearest hundredth of a centimeter, calculate the depth of the water. Okay, so I'm going to reach for my calculator when I'm ready, but what can we do? Let's draw a better picture of this. Nice right angle there. should probably keep that dashed. So right angle, right angle, right angle. P is up here. We would really like the height of this figure. And, so what can we do? Well, we can say by symmetry. I'll draw the picture again over here. And, let's actually leave it a little off center. So it's like I had rotated it slightly. That way I can drop M down here in the middle and still have C back there visible. So let's say by symmetry, PM is height. Well, let's say depth. Where M is it the centroid? Let's just say the center of the circle. I'm pretty sure centroid is the term, but it's been a long time since I remembered my geometry terms. Center of triangle ABC, which, also by symmetry, is equilateral. Alright, now, if I look at PB and then MB, I see I got a nice little right angle. So PM squared is PB squared minus BM squared. Now if I look top down, so there's a top view, C is here, A is here, B is here. M is in the middle, we get MB. I'd really like to know what MB or BM, whatever the length is that you want to call it is. I'd also like to know what PB is. So, what can we do? What can we say here? These all should be related, and then I should be able to find the volume for the whole thing somehow. Okay, the area of triangle AB, well, let's say, I know that the volume is 81 centimeters. (81 centimeters cubed is the volume, and volume for a thing that comes up and meets itself at a point is 1/3 base times height. Look at formulas for, say, a cone or a square-based pyramid. So 1/3 the area of triangle ABC times the height, which is PM. So this is 1/3 triangle ABC times, actually I don't know what PM is. I was about to say 9 centimeters, but no, that's not how that works. So we can multiply by 3 on both sides to say 243 centimeters cubed is triangle ABC times PM. Okay. What can we do here? I'm going to say something like, let length AB be X. Okay, M is here. And I can draw better than that, so it's a BM here. So X here, C up here, A down here. It's all the same length. And it also splits this in half, so we get 30 degrees, 30 degrees. CM will split this in half. So X over 2, X over 2. And what we have here is, if you want to call this D, BDM is a 30, 60, 90 triangle, X over 2 here. So we get ratio of 1 to root 3 to 2. So BM is going to be 2 over root 3 times x over 2. So BM is x over root 3. So we'll say 1 over root 3 times AB. All right. So now I know what BM is in terms of this side AB. But also, in terms of this side AB, we can get that this should be 1 over 2 root 3x. So the area of triangle ABC is 1/2 base of x times CM, which is the same as BM, plus MD, which is half of that. So it should be 3/2, so root 3 over 2 AB, which again we're calling x. So root 3 over 4 times x squared is the area here. All right, so BM is 1 over root 3x. Area of a triangle ABC is root 3 over 4x squared. So root 3 BM is x. So area is root 3 over 4 root 3 BM squared, which is 3 root 3 over 4 BM squared. So that's the area. But we also know the area is 243 over PM, that height. So 243 over PM is 3 root 3 over 4 BM squared. Okay. Then where can we go from there? Well, I suppose I could divide by 3 root 3 and multiply by 4. So I can get 32, 4, so 324 over root 3 PM is BM squared. And then, so we have this relationship here, BM, and there's PM. What's PB? Well, there's a right angle up here. So PB, so if we draw another triangle, PB is going to be AB, which was x, over root 2, because this is an isosceles right triangle. So if you know the hypotenuse, you know the side lengths. So PB is x over root 2, and what did we say x was? Root 3 BM over root 2. So PB squared is 3 BM squared over 2. So 3/2 BM squared. So PM squared is PB squared minus BM squared. But this is 3/2 BM squared minus BM squared. So that should just be 1/2 BM squared. But we just figured out BM squared, 324 over root 3 PM. Multiplied by PM on both sides, we'll get PM cubed. 324 divided by 2 is going to be 162. So 162 over root 3. The depth of water is the cube root of that. Okay. What can we do to make this nice? So that's going to be cube root of 2, cube root of 27, and then 3 over root 3. So cube root of square root of 3. So it should be 3 times the 6th root of 3 times the cube root of 2 if everything has worked out nicely. And that seems like a nice answer, so I guess we could work it out then. Alright. So we'll just grab the calculator. What was it? So depth. So I would always make sure to give the actual exact answer before I started rounding it, just in case the calculator's not the most precise. That way it's very clear. Just make it very clear and then say this to the nearest centimeter is blah. Just makes things nice and neat. So we have 3, the 6th root of 3, and then the cube root of 2. Okay, and so, well, don't have to do anything with the 3, but we'll just grab our calculator here. And the 6th root, oh, it's the different calculator. I have to enter the numbers in differently. So 6th root of 3 is 1.200936. That should be fine. And then the cube root of 3, or sorry, cube root of 2. What is with my fingers today? I'm pressing the wrong buttons. Cube root of 2 is about 1.23999210. So now I can just multiply these 3 times 1.200936 times 1.25999210. And that's 4.53925, yada, yada, yada. And so what do they want? To the nearest hundredth of a centimeter, was it? To the nearest hundredth of a centimeter. Yeah, there it is. Alright, so we take this 9 and we will round up. So to the nearest hundredth. Let's spell hundredth right. We're almost done the contest. Let's not fall to a spelling mistake now. So the nearest hundredth of a centimeter, this is 4.54. And there we go. But we've got our approximation. We've got our exact answer just in case things go wrong. We want to get as many marks as possible. If we can't get perfect, I want to get 9 or 8. I don't want to, just lose marks because it didn't look like I was trying to just pluck the number out of thin air. But there we go. That was the last part, right? Yeah, that's the last part there. So we've got our answer, and that wraps up the 2013 Galois paper. So if you're looking for a bit more of a challenge, I might suggest the Hypatia contest. Very similarly structured, but it's aimed at a grade 11 level. If you're looking for more grade 10 level material, the Cayley paper there's more questions. It's multiple choice. So you look for the 2013 Cayley, for example. But all these options are yours to explore. I'm going to leave it at that. Thank you guys so much for watching. Feel free to like or subscribe if you just want to show some support. If you ever have different ways to approach questions, by all means leave a comment down below. I'm always eager to learn new ways to do things. And that's it for me. You guys have been wonderful. Have a wonderful day. I'll see you around.